Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Hidayah Binti Azmi. My meeting number is 1910200971. So today I will present to you about my about my assignment 2, which I choose to do is classifier. And for the classifier, I'm using CNN convolution neural network. And for the data set that I will be using in this algorithm is the CIFAR 10 data set. So in the CIFAR 10 data set, it has 16,000 images and 50,000 image is already being in training, while 10,000 image in the testing image. So I will explain the package that necessary in this algorithm, where is the torch is for data structure for multiple dimensional tensor. For the torch vision, the package consists of popular dataset, model architecture, and command image transformation. And for computer vision, the torch vision transform is for image transformation. The NPAR, as we know, is a mathematic function. Matplotlib, we know we want to do the graph. So torch and N is for contain different classes that help build neural network model. Torch functional for activation function for convolution operation. And lastly, torch optin is for implementing the various optimization algorithm. Next, we load and normalize the data, where we using torch vision due to its easy tool to load the data CIFAR 10 dataset. And we transform the data in the range of the data set of 0, 1, and we convert the data to tensor and normalize the data to a range -1 and 1. So for the next one is about why I'm using the data augmentation. I'm using the data augmentation due to we want to increasing the amount of data by generating a new data point from existing data. So next, we download the training data, we transform the data, and we set up as the train loader with specific mini batch. Also, we add the num workers here to specify how many sub-process to use for data loading. So next, this is the example I want to show whether the train loader is success or not. Verify. So we print the len train loader, and the next the same part of the train loader we test. We do the same thing as for testing data, where we testing the data, we transform the data, and we set up for the test loader with a specific mini batch size. And then we classes the data into the 10 classes with each plane, car, bird, cat, deer, dog, frog, horse, sheep, and truck. So this is the we can see the land train loader, and we know it's already there. The files already downloaded and it's verified. Next, we will go to define the neural network, where this is the part where we create the convolution. Create or define the convolution of neural network. So in convolution neural network CNN, we include 2 convolution layer with the max pool, and and 3 linear fully connected layer. And for this convolution neural network, we will be using ReLU as the activation function. So the first is we inherit the attribute of the NN model class, 3 input image channels, 32 output channels, this and 5 times 5 square convolution, and then we do the max pooling with the stride of 2, and for we do the image dimension in 5 times 5. And then we run the input data through the network layer by layer. And then we print the net, where the net is to print this output, where the convert to the max pool. So this is the output for define the neural network. Next, I will be implement the loss function and optimizer function, where we use the model NN model to create a cross entropy loss function. Creation equal to NN cross entropy loss, and then we use the touch optim package to set up the function for update the week. Next, we go to train the network. With the the network, we will be training and test for accuracy and train and test for the loss. So the first, we will do the accuracy first, where we initialize this value as 0 for the start each push, and then we initialize everything into the 0, and then we iterate over the training data set, and then we get the input data for the list of input and label, and then optimizer will be 0, otherwise the gradient will be accumulated to existing gradient. And then for this part is about forward plus backward and optimize the image, the output, I'm sorry. And then we accuracy for the training set, this part we predict, and then we print the statistic, and we print training result in accuracy. This is the part where it will print the result. And then we go to testing accuracy. So this part, this is where the part we testing accuracy will be applied, where we initialize the correct and total value as 10, as 0. So since we didn't update the weight based on the test data, we used to touch and grab for this process. Since we don't want to update the weight, so we use the touch nor grab. So iterate number test data mini batch, and then we run the data through the network, use largest output number as a prediction, and update total and correct value accordingly. And then we print result in accuracy for the testing and the test loss. So this is the output of the part of train the network. So this is the one accuracy of the network on 50,000 training image and 10,000 test image, and the loss and testing and train. So next, we go to plot the graph for accuracy for each number of epoch, where we call the training accuracy, testing accuracy, model accuracy for Y label, and X label is for number of epoch. This one. Next, we go to plot of the training and test loss. With this part, we display the graph of training and testing loss per number of epochs, and this is the training loss, and this is the testing loss. And lastly, we determine the accuracy per classes, where we initialize the class correct and class total value as 0 for all classes, and then we call the iterate through the data minibus, and run the data through the network and use the largest output number as prediction, this part. And then for this part, if the predict equal to the true label, C will be 1 for the data point. So okay, next we update the label item class correct and class total value accordingly if it was predicted correctly or not. And lastly, we print out the result for each class correct and total. For this part, overall the model perform much better than random guess. However, for these certain classes, they are likely to have a poor result due to similar feature. Looking at the accuracy per class, we can gain insight into the problem area of the model. So that's all. Thank you so much.